In this lesson, we will be using Hooke's law that states Fx equals Kx. The force required to pull a spring x units beyond its natural length is proportional to x. In this case, K, just for terminology, is the spring constant. So this equation is just used in problems where a spring is being stretched from its natural length. So, for example, a force of 40 newtons is required to hold a spring that has been stretched from its natural length of 10 centimeters to 15 centimeters. So how much work is done to stretch the spring from 15 centimeters to 18 centimeters? First of all, we have to fix up our units because in physics we only use meters in our equations. So 10 centimeters is actually just 0.1 meters. 15 centimeters is 0.15 meters. And 18 centimeters is 0.18 meters. Okay, now, it was given in the question that the natural length is 10 centimeters. So at 10 centimeters, x is actually equal to 0. At 15 centimeters, or 0.15 meters, from 10 centimeters, it was stretched 5 centimeters, which is only 0.05. And then at 18 centimeters, x is actually just 0.08. Now I plug everything into the equation. Fx equals Kx. We were given the force in the first part of the question. So 40 newtons is equal to K times x. And x was 0.05 because we stretched the spring 5 centimeters. Now we just find K, and K is 800. And now we have our equation that the force is equal to 800x. Now, we know that force is equal to 800x, and we just need to find the force from 15 centimeters to 18 centimeters. From the previous video, we know that the total work is equal to A to B of f at x dx. In this case, we know that f at x is equal to 800x. And so work is just equal to 0.15 to 0.05 it's just 0.05 to 0.08 times 800x dx. And that was equal to 800x squared over 2 from 0.05 to 0.08, which is 400 times 0.08 squared minus 0.05 squared. And that is 1.56 joules.